3. All right, number 2, let's run through what we need to do. We've got f of x equals 3x plus 6 over x. So tell me first, do I have, what did I tell you to do first? What did I tell you first up? Factor. What does this look like when you factor? Yes? Do I have any holes here? How do you know if you have a hole? If things cancel, was that you again? Put it on silent. Paris, you are pushing the limit of my patience right now. Click it to silent and put it away. Thank you, dear. Okay. Horizontal asymptotes and vertical asymptotes and this. All right, so look. How do I know if it has a hole? Cancels top and bottom, right? So if I have something as a reminder and it cancels out and I can remove it, remember a hole is a removable discontinuity. For that reason, I can remove it from the equation. So it creates a hole. I do not have that here, so I'm free to move on to the next type of discontinuity, which is a vertical asymptote. How do I find vertical asymptotes? Equal the bottom to 0. So my vertical asymptote here would be x equals 0. Do we agree? Okay. Vertical is up and down. There's my vertical asymptote, yes? All right. That handles all my x discontinuities. How about horizontal asymptote? I look at the degree of the top as compared to the degree of the bottom. So remember, if it's top heavy, what does that mean? No horizontal asymptote. If it's bottom heavy, y equals 0. And if it's the same like it is here, that's right. So in this case, that would be y equals 3. So I go over, or I go up to 3. All right. X-intercepts. How do I find x-intercepts? Equal the top to 0. So if I want to know x-intercepts, I say 3x plus 6 equals 0. 3x is negative 6, so x is negative 2. 1, 2. All right. That's all the new stuff from yesterday, right? Now I just need to graph. Oh, y-intercept. Okay.
Oh, never mind.
Yeah. Y equals 3. Okay, so these are your scenarios. If I'm top heavy, these are only for your horizontal asymptotes. If I'm top heavy, there's none. Bottom heavy, y equals 0. And if they're the same, then I do the leading coefficient of the top divided by the leading coefficient of the bottom. It's the ratio of those two. So it's 3 divided by 1. Yeah. Set the bottom to 0. So vertical asymptotes are denominator equal to 0. With the holes removed, though, because remember, holes are when factors cancel top and bottom. All right. Now, I need at least 2 points on either side of the vertical asymptote. Okay? I've already got one on the left. So what I do, what you got? Yes. By the way, what's my y-intercept here? None. Remember, y-intercept is found by letting your x be 1, but if you look, I don't even have to calculate anything. If there's an asymptote on the y-axis, I can't intersect an asymptote, right? So there's none. All right. On your calculator, you're going to put this function, and then you're going to go into your table. No y-intercept. There's none. If you put a 0 in, if you do f of 0, you get 3 times 0 plus 6 divided by 0, and you can't divide by 0. So I'm on my calculator, and I don't have one with me up here, but somebody that's got one. Plug this in, y equals, and go into your table. You got one, Armando? Oh, yeah. Okay, thank you. None. All right. Yeah. So I go to my vertical asymptote. That's a good question. Did everybody hear? Yeah. For the table here, I look at my asymptote, my vertical asymptote. I go 2 to the left, and I've already got one of those. That's why I just did -1. And then I go 2 to the right, so 1 and 2. So every asymptote will produce 4 different points for you. Okay. All right. Every asymptote should produce 4 points for you. Go 2 to the left and 2 to the right. So if you have 2 vertical asymptotes, then you're going to have 8 points. Yeah, but that's already my x-intercept. There's already a point there. Yeah. If you included it, it's fine. You would just find a 0. Yes. Yes. 2 on either side. All right. Somebody with your calculator in this problem plugged in, tell me what you get when it's -1. -3. -1. -3. This is enough. The point is that I've got enough to pick up the pattern, right? And you can see how it's going to come in and hug the asymptote from this direction and hug the asymptote from this direction. What about at 1? What's the y value when x is 1? What is it? 9. Great. Hey. 1, 9. 1, 2, 3. We're just going to go right here. So that's 9. Put it in parentheses. The top needs to be in parentheses. Yeah. All right, how about 2? What happens when you plug in 2? -1 is -3. 1 is 9. You don't do anything. You gotta put it in. Yeah. You just tell it what you want it. Yes. Be very careful when you put these in, guys. Make sure your top is in parentheses. You can. Yeah, you can. Doesn't matter. All right, look. Guys, y'all are awful chatty. Yeah. Did you input in your y equals, you've got a parentheses around the top like this? All right. What's the domain, guys? I'm leaving out which x value? X, which x? 0. So -infinity to 0, 0 to infinity. How about the range? Good. It's because what? Yes, if it was a whole, you'd leave it out. On the left and right. Guys, yep. Every time, and you might have 2 or 3 vertical asymptotes. Every time you have a vertical asymptote, go 2 left, 2 right. 2 left, 2 right. But you're going to use your calculator to find those values. I guess it would depend on what you go to school to do. Engineering, you would probably use this a lot. Yes. Yeah. Guys, I can't even hear the question. Yeah. Your calculator is not going to show you asymptotes, but is it bounded? You're talking, stop it. That's it. We already answered it. Guys, listen. I try to give y'all a little more freedom than what I give Algebra 1 and Algebra 2, but I clearly need to cut it. Okay. Number 3. Ticked off. All right. Look. You're looking at the degree of the top compared to the degree of the bottom. So top heavy means yes. That'd be the same. So it would be, it's the leading coefficient of the top divided by the leading coefficient of the bottom. So it'd just be 1. All right. All right, my first step on this is to factor, yes? Yeah. I can shortcut this, Harris. How does it look once you factor it? Why don't you guess? Look at the top. Oh, wait. What? The difference is square. It's not that easy. But it's a shortcut, because what multiplies to -12 but adds to -4? Harris, why don't you try anymore? You don't even try. No, you don't. -6 and +2. Now, what multiplies to -12 but adds to -4? +2. All right. Malaya says we have a hole at -2, and she's exactly right. Those cancel, which creates a hole at -2. Okay. So what this graph really looks like, this is a really easy graph to do. This is just a line that has a hole in it. There's no vertical asymptotes, right? Because that I look at after, so there's none. There's no horizontal asymptotes because I'm not even a fraction anymore. It's a line, right? But if I put it over 1, I'm top heavy, so there's none. All right, so if I graph this, I start at -6. 1, 2, 3, 4, 5, 6. My hole, where does my hole happen? At -2, what's the y value that goes with it? How do I find the y value that goes with my hole? You plug it in, right? I plug it in. So f of -2, come on, f of -2, and I'm plugging it into this equation after I canceled the hole out. So f of, I just wrote f of -2. That's weird. -2 minus 6 is -8. That means my hole occurs at the point -2, -8. So I'm just going to plot that on my graph here. -2, -8. Here's my hole. Now I have 2 points that I can just connect, and there's my line. Okay? It is literally a line with a hole in it. Yes. So if I need my, let's say, x-intercept, that's where I put y to 0. My y-intercept, that one's really easy because I can get that as mx plus b here. What is my domain, though? You're close. I gotta leave this out. I gotta leave out the hole. You still gotta leave it bottom, huh? For my range, it's definitely going down forever, but as I make my way up, there's no y value anywhere right there. And so I got to leave it out, right? And that y value we said was -8. Yes, holes and asymptotes get left out. No, you weren't. Don't tell a story. None. None. Because this graph has a hole right here. So as I move from the bottom up, I skipped that space. All right. One more. We'll do 4 together. -6. 6. Yeah, you can pick whatever 4. We're going to do the other 4 today. All right. Yep. And then I'm going to add a little something to it today. It's going to be... All right. Factor everything. Harris, get your crap together. Factor the top, Harris. It has a GCF. What's the GCF?
What does that mean?
Take out an X. What's left whenever I take out the X? And then on the bottom, how does that factor? All right, this one has got a hole and a vertical asymptote. So look very carefully. The hole happens when I cancel something out, right? So I've got a hole at -3. Now I got to find the y that goes with that hole. Let me show you. I just plugged -3 into the equation after I've canceled. So the y part would be -3 over -2, which is, so the hole happens at -3, 3. Okay, that's my hole. How about vertical asymptote? How do you know? The bottom goes to 0 after I remove my holes. After you remove the holes, I set the bottom equal to 0. And that's how I get -2 for my vertical asymptote. So far, verticals are just bottom to 0 after you strike out the holes. That's -3, 3. X equals -2 is my vertical asymptote. All right, how about horizontal asymptotes? How do you know? That's right. I've got the same exponent top and bottom, which means I do leading coefficient of the top divided by leading coefficient of the bottom, which is y equals 1. That's a horizontal line at 1. Okay? That's your top heavy, bottom heavy are same. It's for this one, since it's the same, it's the leading coefficient of the top, which is 1 divided by 1. The number in front of x, yes, yes. All right, now do your XY chart. Tell me what points, now I already have -3. Even though it's a hole, it's still a point on the graph. Now let's also do negative, what do you think? -4, I would do -4. What other points should I use? I got -3. -5 is going to be over here. -1 and 0. Look, here's my asymptote. Go 1, 2, and 1, 2. Okay? Just make sure. Here's my asymptote. Go 1, 2, 1, 2. Right, right. And because this hole is right here, I can use that as one of my points. I'm just going to lift my pencil up whenever I get there to go. All right, so use your calculator. Be very careful as you put this into your calculator. Make sure you got parentheses in there and everything looks nice and neat. What do you get for -4? What is it? 2? How do you do what? You're going to just make sure you have parentheses. You're going to need parentheses around the top, parentheses around the bottom. Yeah. How about -1? -1? How about 0? 0? Yeah. All right. What is my domain? -3, because I got to leave the hole out, right? Remember, holes and asymptotes. And then I have to pick up from -3 and leave out that asymptote at -2. Did you get it? It stops at, yeah, yeah. Yes. Yeah. Yes. It's your table. Do y'all need me to hook up my camera? Oh. You might have your settings wrong for your table. Go second. All right, how about the range? Yeah. Hold on. No, okay. No, that's okay. -infinity to 1. All right. What was your question, Lee? X-intercept. Yes. Okay, but when you do that one, right, right. So x-intercepts you can always know to just set the top to 0 and solve. Say that again. The y-intercept is putting a 0 in for every x. Yeah. So for the x, when you do for the x-intercept, you're going to take the top, but take the top of your, once you canceled that hole out. Yes, yeah. Well, so if you do it from here, you'd get x equals 0 and x equals -3, but -3 is not an intercept here. So you have to remove that. Look at your graph. It's not crossing at -3. Yeah. So does everybody hear that? Take the hole out before you find the intercepts. Take the hole out and then find your intercepts. Yes. X over x plus 2. For the y-intercept, it would be 0 because 0 over 2. Yeah. And you can look at your graph, it's crossing at 0, 0, so your x-intercept is 0 and your y-intercept is 0. No. Yes or no? To show you, I'm so glad you asked, Luke. I'm so glad you asked. My boys at the back are rowdy. Do it after you've taken the hole out. So after you factor it and cancel something out, so then you have x over x plus 2, use that to find your intercepts. No, because it would give you an x equals -3, but that's not one of the intercepts. You have to cancel it out. You can. All right. Let me talk to you for just a second about one more concept of rational functions. Now, we've done a lot of the ones, I think most everyone you've done so far looks like this. Did you have any of the ones on there that look like this? None like that so far? Okay. It's coming. Now, today what we're going to look at, sometimes when you do a rational function, I showed you one yesterday where it kind of looks like this. Well, in this, what happens is there's actually an asymptote, but it's not vertical nor horizontal. It's actually what we call a slant asymptote. Which means it hugs this kind of slanted line. Yep. Slants are easy. They're not as hard as you think they are. It is. You just have to be able to graph a line. That's right. Sometimes these are called oblique. OBLIQUE, oblique asymptotes. All right. There's only one time it happens. It's only when, whoa, I don't know what that word is. It's not when. Only when, that's a good guess. No. It's only when the degree of the top is exactly one more than the degree of the bottom. That is the only time you will have a slant asymptote, but every time that happens, you have a slant asymptote. So, nobody's asked the question. Why do we do this? Not that question. Do what? You did, so that one would have had a slant asymptote. We just didn't do it. All right. That's the question I was looking for, Gianna. Thank you. So how in the world are we going to find a stinking slant asymptote? What the heck? Well, I'm so glad you asked. What? Y'all are going to love this. Are you ready? But how do I divide polynomials? Oh, I remember that. Heck no. No. Wait, no, I no. That was no. I think I got like a. That was the only thing that I had. And algebra two. Yeah. Are there going to be some cases where I have to? All right. What? Are there going to be some cases where I have to? Okay. When we divide one polynomial by the other, we get the equation of the slant asymptote. We ignore any remainders and we just take that on top. It's always going to be linear every single time because we're only 1 degree off. So you're never more than 2 steps in to find it. Okay? It's not the big long polynomial problems like you did in algebra 2 because you won't have more than 2 steps, but it could be quite involved. Okay. Let me run you through an example first of just the slant asymptote, finding it, and then we'll do one where we graph it. Yes, Armando, what's wrong? Why do you keep doing that? You know you can click my picture and it takes you to me. Well, I was. I don't know. There we go. Thank you. You're welcome. Okay. For example, slant asymptote or nah? I hope not. Yes. Yes, there is a slant. How do I know that there is a slant? 1 degree higher. Now, what happens when I am a higher degree up top than I am in the bottom as far as horizontal asymptotes? I have no horizontal asymptote, right? Because I'm top heavy. So slant asymptotes will never have horizontal asymptotes. They may have vertical, but not horizontal. Okay. Say it again. No, no, it's got to be exactly one more. All right. All right, everybody, exactly one more up top. If that was a 6x cubed up top, Nope, wouldn't work. Okay. Yes. All right, let's run through. Let's run through and make sure you remember how to do division. Can I use synthetic here? No, because there's a number in front of the x, right, Armando? I can't do synthetic if there's a number in front of the x or any exponent. So I got it. It's got to be. Remember, synthetic. Synthetic is only when I divide by x plus something or x minus something. Okay. All right, Armando. Yay, day.
What does that mean?
All right. I'm going to go ahead and set up this division, okay? 3x plus 2 goes on the outside. Inside, don't forget placeholders if you need them. This is long division. You have to, whatever the biggest degree is, you have to have that one and every one proceeding down from there until you get to the constant. If you're missing one, you hold the place with a 0. All right. It'd be 0x minus 11. All right. Guys, I feel like I am fighting you to show you this. This is long division now. I'll show you a synthetic one. All right. What do I multiply 3x by to get 6x squared? 2x. It goes in the x column. Okay. Now I multiply around, but whenever I multiply around, I multiply to everything. 2x times 2x times 3x, 2x times 2, and remember I'm subtracting all of these things, yes? 6x squared, 6x squared. It's just, that's the rules for the division. And then I bring down the next term. In this case, my x is canceled out. What now do I multiply 3x by to get 11? You can't. That is my remainder. Do not worry about your remainder. Once you get to that point, you take what's up top and you go, okay, I have a slant asymptote at y equals 2x. You only look at first terms. It's always just first terms. Yeah. Because 4x minus 4x is 0x. Sure you can. What does 2x look like? That's got a y-intercept of 0, and it's got a slope of 2. So up 2 over 1, and that's my asymptote. I don't worry about the remainder. I just divide. So 3x goes into 6x squared how many times? Yeah. All right. I don't know. Every time I look up, you're talking. All right. Listen. Yes, you multiply that to everything. It goes to everything. But you're subtracting all of it. So I'm saying, what I'm really saying is 6x squared plus 4x minus 6x squared plus 4x. 0. Yes. All right, let's do another one. Don't forget how to graph a line. I start with the y-intercept, which is 0, and I apply the slope up 2 over 1. All right, let's do another one. It won't have a horizontal asymptote, but it could have a vertical asymptote. Yes. Like for instance, this one will have a vertical asymptote at -2/3, which happens over here, and it's going to end up looking like this. What happens on this graph is it ends up doing something like this, and it hugs both asymptotes on the side like that. So it can have both. It just can't have a horizontal if it's this way. Up 2/1. You almost said it got on my nose, dude. I missed my whole mouth. It's all in my hair. That was nasty. Okay. She was just asking how we subtracted them. Let's do another one. Okay. All right, before you graph this, what I'd like for you to do is find all asymptotes of all kinds. Find vertical, horizontal, and slant asymptotes if applicable. Huh? All right. Yes, I would always factor first so that I can do a little analysis here. What do you notice? There's a hole. There's a hole. There's a hole. Where is there a hole? Why? I can remove it, so it's a removable discontinuity. Okay? All right. It also makes my equation much easier to work with. How about horizontal asymptotes? Okay. Guys, this is getting very, I know people up here are getting frustrated. All right, horizontal asymptote, Luke. None, because it's top heavy. That's exactly right. How about vertical asymptote? At 1, how do you know? I set the bottom to 0 after I've removed the holes. Okay, everything's after I've removed the holes, right, Rhett? What are you looking on that computer? Okay, so the next question is, does it have a slant? Okay, I heard it does. How do you know? 1 degree above. Always after you've removed the hole. Yes, yes. No matter, always factor. Always factor. Because you always want to remove any discontinuities you can. Okay, so it's yes. So now look, here's the problem, all right? I can set this up this way. I've got x squared plus, I got to do my placeholders, right? Or the bottom always goes on the outside. Yeah. You could. That's what I'm fixing to talk about. All right, so now look at this though. For this one, I could do synthetic if I chose. I'd get the same thing. Because it's just x minus 1, I could do, you put the opposite sign of the number, so 1, upside down division sign.
No. Okay, missing you. No.
Okay. I'm trying. All right, guys, listen. We are not going to make it through this together if y'all cannot get it together. Okay, seriously. We are literally reviewing an Algebra 2 concept and y'all have not stopped. I need you with me, okay? This is synthetic division. I can do synthetic division when I divide by x plus a number or x minus a number. That is the only time. There's no coefficient, there's no exponent. What I do is I take the sign opposite the number, this goes outside. Then I list all the coefficients of what I'm dividing by with placeholders. 1, 0, 0 goes in here. I start by dropping the first, multiply and add, multiply and add. I would continue that process until I was done. Multiply, add, multiply. It's always drop, multiply, add, multiply, add, multiply, add, multiply, add by the number on the outside every time. And then I interpret my answer. I start from the far right, that's my remainder, but remember, I'm not worried about remainders for this scenario, okay? Then this is my constant and my x. What is the equation of my slant asymptote? Y equals x plus 1. Just to show you, if I come back over to my long division, what do I multiply x by to get x squared? X, multiply around, x squared minus x, and subtract. On the long division or the synthetic? So you take the first term and you say, what do I multiply that by to get the first term inside? Then you put that on top. And then you multiply it around to the outside. Yes. When I subtract 0x minus negative x is just an x. And I bring down the next term. And now I do it all again. What do I multiply x by to get x? 1. What would be a negative? No, because you're subtracting. So it's 0x minus negative x. Because when you multiplied around, there was a negative sign in here. Which last step? What do you multiply x squared by to get x? I mean, what do you multiply x by to get x? 1. Nope. Yes.
What is the 0x? Okay, so put the x on top.
So 0x minus negative x. 0x minus negative. It's negative because when you multiplied through here, this was minus 1. So it was x times x times x minus 1, which would be x squared minus x. Right. That one does have a slant. Which negative? I multiplied the 1 to everything outside. So 1 times x minus 1 would be x minus 1. I haven't, this we did, remember you take what's up top, that's your equation, x plus 1. Okay, what does that look like on a graph? Well, right now, and we've not even graphed the rest of it, but right now, I've got a vertical asymptote at 1. I've got a hole at -3, wherever that happens to be. We'll do that in just a minute. But I've got a slant at x plus 1, which means start at 1 and go up 1 over 1. My graph here is bounded this way and this way, okay? Yes, it'll have a hole at -3. So, right, so I would go on my T-chart again, and I would pick up some points. Remember, I need at least 2 on either side of every vertical asymptote. So I'm probably going to go 0, but in this case, you really have to look at it because I also need to make sure I include something in here because I need to find out what's happening, right? So I'd probably look at that -3 where that hole was, right? What does that give me? Well, f of -3 after I take out the hole would be 9 over 2, right? Nope, it's -3. Nope. Sorry. -2.25. So 1, 2, 3, 1, 2, 3. It's gonna be somewhere around here. And you'd have another point in here so that you could do enough to pick up the pattern here. Mm-hmm. 0, the asymptote's on 0 here. You're not gonna have a point there. I haven't done it yet. I was just, right now I'm focusing on getting y'all through the asymptotes. Yeah, that's where the hole is. Why what? Oh, you know what? The x0 or the y0? You can. That's my fault. You can. You can put a 0 in. If you put a 0 in here, you get 0, so 0, 0 is actually a point. So it's going to do more like this. Yes. Let's do another slant.
I think our homework is on. Yeah,
Say again?
what point did you put the one up there?
I didn't yet. I'm fixing to do a full on one with you all the way through with slant asymptotes. All right, what I want to do is one full one with you all the way through with slant asymptotes with every single type of analysis that you'll have so far. No. I'm fixing to tell you about your homework. All right, here we go. Start to finish. Ready, Freddies? We'll go slow, yes. That is correct. I always want my first step to be factoring and removing any holes, okay? I always want to remove what I can before I even start. All right, so for the top, this one, it might have a slant. Dang it. Man, that was I was trying to do a hard one with y'all. Okay, I'm gonna just. Okay. Let's factor and remove. What's wrong, Luke? There's what? I know. Well, your buddy has fallen asleep, so now you don't have anybody to talk to, so now you gotta talk to me. All right. All right. Factor, and this can't be shortcut. But I can slash. What multiplies to 30x squared but adds to 11x? 5x and 6x, or 6 and 5. It doesn't matter what order you do it in. I'm going to come off to the side, and I'm just going to factor this for just a minute. 6x squared plus, I think I'll do 6x plus 5x. It doesn't matter. That order doesn't matter. You're going to come back to the same thing. Take out a 6x. You understand why I could not factor this, right? I mean, why I could not shortcut this. That's right. Do I have any holes? What creates holes? There's no holes, so I can't cancel anything out. Well, rats. All right, so tell me, so holes would be none. No holes. Okay, but I do have a vertical asymptote. Where is my vertical asymptote? -4/3. I set the bottom equal to 0 and I solve it, right? All right. The top to 0 are your x-intercepts. The bottom to 0 are your vertical asymptotes. Harris, put that up. The x-intercepts would be when the top goes to 0, right? I have 2 of them. What are they? -1. Subtract 5 divided by 6, right? I don't think any one of these steps is terrible. It's just that there's so many. All right. Horizontal asymptotes. There's none. How do you know? Right. I did forget the y-intercepts. How about, because there's 2 up top and 1 in the bottom. That's right. Y-intercepts. So this one I put a 0 in for every x in my equation, right? Look, I would go back, since I couldn't remove anything, I would go back to this original to plug in zeros. It's 5/4. You could, but you'd have a little more. You'd have 1 times 5 divided by 4. You can put it in either one. You just need to make sure you take the holes out before you do anything. This one didn't have any holes to take out, so it's okay to use whichever one. Take them out. Right. All right, now for the good stuff. Slant asymptotes. Do I have one? How do you know? 1 degree higher up top than in the bottom. So I must divide. Can I use synthetic division? No, because there's a coefficient in front. So I got 3x plus 4 into 6x squared plus 11x plus 5. Remember, 2 steps with my division because I don't worry about the remainder. If you'd taken a whole out, you'd use the equation after you took the whole out. All right, what do you multiply 3x by to get 6x squared? 2x. Second column, multiply around and multiply to both of them. So 2x times 3x, 2x times 4, 8x. But I'm subtracting all of this, okay? First one's cancel. What is 11x minus 8x? 3x. Bring it down. Now, what do you multiply 3x by to get 3x? Positive 1. Multiply around, and it doesn't really matter because I'm not worried about this remainder. I'm only worried about this. That's exactly right. So my slant asymptote is y equals 2x plus 1. Okay,